What's poppin', dogs? Mr. Allen here. We're about to solve for x in this rational equation here. We got ourselves a beast. We got some factor we got to do. I got to get a common denominator when I am solving rational equations. So I got to factor each denominator where possible first. This guy right here, I can take on an x, and I'm left with x times x plus 1. Same goes for this one, x times x plus 1. That one cannot be factored. It's just got that x plus 1. So what's my least common denominator going to be? Well, my common denominator is going to be x times x plus 1. Because if I got this guy and x right here, they would all be the same. So x times x plus 1 is my LCD. And right now, I can go ahead and get my domain restrictions. It's whatever makes my denominator 0. I cannot divide by 0, so my domain restrictions are whatever makes my denominator 0, because that'll cause me to divide by 0, thus making the whole problem undefined. All right, so x cannot equal 0. Right? Because if I plug 0 in here, it's 0 times 1, which is 0. And x cannot equal negative 1. All right, there's our domain restrictions. That's beautiful. That's fantastic. Now, what I'm going to do is I'm going to get a common denominator for each one of these fractions, right? Well, I've already got a common denominator here, right? My LCD, rather. I've already got my LCD here. I've got it here, too. What's that third fraction right there need? That needs an x. So I'm going to multiply by x over x. That means I am multiplying by 1. Does multiplying by 1 change anything? No, it does not. So that's why it's legal in math land to multiply by x divided by x, because it's really just 1 and it doesn't change it. But it's going to look a little bit different, right? And that's the whole point. So this one up here, I've got x plus 5 over still x times x plus 1. That one does not change. Here I've got 1 over x times x plus 1. That one doesn't change either. But the last one here, minus x times x minus 6 over that x times x plus 1. Do I have all three denominators the same now? Absolutely. So let's think about this for a sec. If all my denominators are the same, couldn't I just figure out what makes my numerators equal? Woo! That's right. That's right. I can go ahead and simplify this thing out. I'm going to take out all my denominators. I'm just going to write x plus 5 equals 1 minus x times x minus 6. This is just one way of solving rationals. There are a couple ways of doing it. So I'm showing you guys this way because guess what? It's my video and I get to choose, right? Okay, so now I'm going to solve this single line equation here, just like Algebra 1 stuff. Oh, it's beautiful. Distribute that negative x, all right? Don't miss that sign there. So we have x plus 5 equals 1 minus x squared plus 6x. Oh boy. We have ourselves a quadratic here, children, okay? We have ourselves a quadratic. And anytime a quadratic seems to pop up when solving equations and you're not expecting it, you panic and you do all sorts of illegal math moves. All right, if I want to solve a quadratic equation, I need to set it equal to 0. That's pretty much our go-to method, okay? Now, another pro tip here. Do not have a negative lead coefficient for your quadratic term. So I'm going to add x squared to both sides. So add x squared. I'm going to subtract 6x. So minus 6x. I'm going to subtract. I'm doing all this at once. This is crazy. Let's stay organized, though, shall we? So if I add x squared over, I'm going to have x squared. I've got x minus 6x. That's negative 5x. And I have 5, negative 1. That gives me positive 4 equals 0. Woo! Now, this might look a little more familiar. What multiplies to 4 and adds to negative 5? Well, that's going to be negative 4 and negative 1. Boom, diggity. Now I can set my two factors equal to 0. X minus 4 equals 0. X minus 1 equals 0. So I get x equals 4, and I get x equals positive 1. Now before I go ahead and circle these things and say, hey man, we're all Gucci on the streets, we're good to go, I got to check my domain restrictions. Do either of these two solutions match those domain restrictions? No. So that means that these two are good to go. Had this been like a negative 1, it would be considered an extraneous solution. We'd cross that bad boy out. We can even notate that it's extraneous, right, if we're feeling bougie. So there we go. We're good to go. These are our two solutions. It doesn't match a domain restriction, so it will not cause the original equation to be undefined. All good, awesome, fantastic, and America. See you dogs later.